Hi, welcome back to Knowledge Hub by Srichaitanya. In the previous video, we discussed about hybridization. In today's video, let's discuss about molecular orbital theory. Let's see one of the question on it. If you see the question, the bond order and magnetic behavior of O2 minus ion are respectively. See the options what are given: 1.51 dia, 1.51 para, 1 and para, 2 and dia. In order to solve this question, we need to know about a trick behind the given question. So let's solve the question by taking a molecular orbital theory concept. What is the concept? When you see molecular orbital energy diagram, we need to draw for any diatomic species all the time. If you know the energy orders, these are the energy orders if number of electrons are greater than 14 or less than or equals to 14. And if you see the molecular orbitals which are given, here we have sigma as well as pi molecular orbitals along with sigma star and pi star anti-bonding molecular orbital. Here bonding molecular orbital, anti-bonding molecular orbitals, we can get the energy orders based on the z-axis orientation. Here z-axis along the energy orders given for number of electrons less than 14 and equals to 14 along with number of electrons greater than 14. Then what to do? We need to fill electrons in these all energy orbitals. So based on the Abbo as well as Hund's rule, we need to fill electrons. Why again Hund's rule? The reason, here we have there are degenerate orbitals. When degenerate orbitals, whether it is atomic orbital or molecular orbitals, we need to follow Hund's rule to fill one electron in each molecular orbital. Then only we should start pairing the electrons. Let's see shortcut to answer this molecular orbital theory based questions instead of going for molecular orbital energy diagram. What is the shortcut? This is the shortcut what we have. If you know number of electrons in diatomic species, directly we can take the bond order which is 3. And just if you know the number of electrons in diatomic species, we can directly go for bond orders. This is the shortcut which we need to follow to answer the question simply. In order to know the magnetic nature, there is another shortcut method which we need to follow is if number of electrons or odd number of electrons, the magnetic nature is going to be para. If number of electrons are even, then the magnetic nature is going to be dia. But this exception we need to remember, that is for number of electrons 10 as well as number of electrons 16. When we have 10 and 16, the magnetic nature is para as well as para for these diatomic species with even number of electrons. Let's see one of the example, and in order to answer any question even on the relationships. What are the relationships for us? Bond energy, bond order, bond length, bond order. For taking one simple example, nitrogen. See the nitrogen example in which all nitrogen diatomic species we have. Whereas nitrogen is having number of electrons 14, so bond order is going to be 3. And nitrogen with plus 13, nitrogen with minus 15. Both are having same bond order. In this way, we can calculate bond order for these diatomic species. Let's see our question now. The bond order of O2 minus and magnetic character. O2 minus is having number of electrons 16 plus 1. The reason oxygen atomic number, if you see 8. There are 2 oxygens. Definitely total number of electrons is going to be 16. And minus charge also present. So total electrons are 17. If 17 is odd, so answer must be between 2 and 3. For 17 number of electrons, the bond order is going to be 1.5. In this way, simply we can answer bond order based questions if given. Let's see one more question. The bond order for diatomic species of oxygen. O2 plus, O2, O2 minus and O2 2 minus are given, and simply they are asking bond order increasing order for the given diatomic species. First of all, calculate number of electrons in each case. We already know oxygen is having 16, O2 minus is 17, O2 minus is 18. What about O2 plus 15? In this increasing order we can directly take. If number of electrons are 15, the bond order is going to be 2.5. Then O2 is having 2, O2 minus is having 1.5, and finally O2 2 minus is having 1. So the answer is going to be first option. If the same question is being asked for bond energy, the order is going to be same as we have the relationship bond energy and bond order. If the same question is being asked for bond length, order is going to be reversed. I hope this shortcut helpful to you. So let's meet in the next video. Thanks for watching.